Good afternoon, everyone, and thanks for joining us here at Total Water Solutions. As promised, we intend for this session to be a very short, sharp 20-minute webinar on two topics: Legionella control and water efficiency in schools. A few bits of housekeeping. The session will be recorded and published onto our social channels, but don't drop off now because broadcasting live, you get to catch any of our bloopers before we edit them out. We don't have a Q&A running, purely due to the fact that we want to keep this session length to 20 minutes. However, we of course welcome any feedback, questions, queries you've got. Ultimately, you've all invested some time to be here today, which we appreciate, and we want to make sure you get what you need to from these sessions. Okay, so we have two speakers today, and for those of you that already know Andy Sinclair and or Michael Dean, you'll know they're both very passionate about their subject areas, and as such, and as they have reminded me, could talk for hours about their topics. So the job of keeping them on track and on time will fall to me. So if you hear me interrupt a few times throughout the presentation, you know why. The irony is not lost on me, however, that I've already gone over my allotted 1 minute time, so we'll make a start. So hi, my name's Carl Hunter. I work in business development at Total Water Solutions, which is part of the Northumbrian Water Group, alongside the utility brands of Essex and Suffolk Water and Northumbrian Water. Effectively at Total Water Solutions, we're a trusted go-to for all water-related matters for non-domestic customers. From the two topics we're covering today, all the way through to things like industrial liquid waste, we cover all aspects of supporting organisations manage and support, optimise their private water networks. So without further ado, I'm going to hand over to Andy to talk you through the benefits of water efficiency in schools. Over to you, Andy.
Thanks, Carl. So I'm going to talk a little bit about water efficiency today and why particularly it matters in schools. Often the first thought when we talk about water efficiency, we're actually looking at a financial saving, and that's a valid reason for looking at it. I mean, obviously we want to be making sure that we're spending all the resources available to schools on the things that are going to benefit children's education, and spend that on water that's potentially leaking away is not a good use of that money. So it does bring it to a focal point for most conversations. However, there's also environmental benefits as well to being water efficient. We know that obviously by 2025, schools were supposed to appoint a sustainability lead and also have a climate action plan in place, which does make special mention of water and water efficiency. The thing with water is it's generally a bit of an overlooked utility, mainly because gas and electricity tend to be a little bit more expensive per unit. However, there are some good savings for the environment and carbon wise as well. When we're looking at water, we've got to treat it, we've got to pump it, and generally about 50% of water is heated in a domestic situation. All of those things cost energy and carbon to do and deliver. The other thing that we've got to bear in mind as well is it's a finite resource. We sometimes forget, we think there's a lot of water on the planet, but there's only about 2% of it that's actually usable from a drinking point of view. So what we want to do is make sure we're using water effectively and efficiently to make sure that we don't get ourselves in a position where we've got water shortages or droughts. We operate, as Carl said, in the southeast as well, where we have one of the driest areas in the UK, so that kind of brings a bit of focus to it. So what can Total Water Solutions offer for schools? As Carl mentioned, we are a trusted support for organisations, and being part of the water company, we're all about water related services. More often than not, what will tend to happen is people will get a nasty bill, and they'll realise that their water consumption's gone up, and they'll need some sort of leak detection. So obviously we can come and support with that. We can also support with the repair. So we will dig down, proper engineering work, dig down in the ground, repair that leak, backfill it, and reinstate it to the way that it was previously. We also do a range of audits, which are can start from a very simple look at your school, through to a full on-site audit where we get an engineer on site to go and look at everything, look at all the cupboards, look at all the assets, and give you a full roundup of the ways where you could be that little bit more efficient, and hopefully save some money and be a bit kinder to the environment. We've also got fire hydrant testing on there. That's an important one. Water is useful, and it should be used in the correct way. And fire suppression is absolutely one of those ways where water can be a benefit. However, a lot of the time when we go to maintain the fire hydrants, you'll be surprised how often we find them in the weeping or leaking. So it is a valid point to check on those as part of your annual inspections. Um, Automated meter reading is in the center then for good reason. It kind of can tie all of these things together. Automated meter reading is smart metering for water, a bit like what you'd have in your domestic property for your electric and gas. We've got this for water. What we've got here is we've got a bit of a case study of some work we did recently. So um, we were working with the council who were wanting to investigate large variations in water. Could they be more efficient and anything to sort of related with that? We installed AMR3 of their schools. We found at two of those schools that there was actually a leak present. And as Carl will scroll into this graph so we can see that in a little bit more detail. What you can see here is this is consumption over time. So what we can see there is the blue is the actual result. And what we would expect to see in a school situation, particularly, is actually on a night time and on weekends, school holidays, things of that nature, there should be little to no use. In theory, and what we can see here is actually the green. That's what we would expect to see. The blue is what we're getting. So that difference between the two is a leak. So when we've looked at that, it came to about 4 meters cubed a day. So that's a little over 4,000 liters of water per day, which is can be quite difficult to kind of sort of conceptually think about. But we've got some helpful infographics here for you as well. So that 4 meters cubed or 4,000 liters of water a day equates to about 81 5-minute showers. We'd always recommend a little bit shorter showers if you can manage it. People with long hair or beards like mine might take a little bit more, but if you can keep them under 4, that's good. We're talking about full bathtubs here, not the kind that, unfortunately, because I work in water efficiency, my kids get. I'm talking about full spirit level to the top, bubble, luxurious baths. So 53 of them, so that gives you an idea, or 81 washing cycles, which I'll probably do in a week with my 2 kids. But it just gives you an idea of being able to conceptualize how much water was being lost at that particular school. So if we go to what are your options? So basically, you've got kind of two options really. One of them is that you don't do anything. Now, bearing in mind that a meter cubed of water on the retail market's about 170-ish a meter cubed, I think, from my last checking. So that volume of water being lost would cost the school around, well, just under £5,000 a year, which I'm sure we can all agree would be better spent on more resources for kids and not being wasted into the ground and not used. Um, Option B is that you do something about it. And as I mentioned, the services that we offer, we could come and find that leak for you. We could dig down and do a standard repair. So that would be in a soft verge. When I talk about reinforced concrete, that's a little bit more, but in a soft verge where most pipes are, and you would also get the 5-year AMR subscription as well, and that would come in under 4. So if you went down that route, basically you'd have your leak repaired. Your school would also save around 1,377 kilograms of carbon, which is great and not to be sniffed at. But the real benefit in there as well is the fact that you've got that automated meter reading in the ground for 5 years. What that allows you to do is spot any potential leaks in the future, but also gives you the added benefit if you're going to do some sort of initiative in the school where you're going to look at water efficiency, you'll be able to validate it because you'll be able to have to, well, this is what it was before and this is what it is now afterwards. So, added benefit there as well. So a little takeaway for you today. Obviously, it can be quite difficult to understand whether or not you even need to look at this sort of thing for your school. So this is a little bit of a rough and ready calculation, but it will give you an indication. So if you get your water bill, more often than not, it's in meters cubed, like we talked before. So if you times that by 1,000, you'll get that in 2 liters. If you then divide that number by the number of school days, which on average is about 190. Might be slightly different if you've got activities on the weekend, for instance, or through the school holidays, which might change it. So make sure you include that. If you divide that number by the number of students and staff in your school, what you'll get is you'll get a consumption per head annually in litres. So you can then compare that against, for a primary school, we're looking at about 7,000 litres a year per person. And in a secondary school, we're looking at about 11,000 litres per person. So that'll give you a really good indication of whether or not you need to do something about it, or actually you're pretty comfortable, and that's great. But obviously, if you've got any questions, please do get in touch with us. Thank you.
Thanks. Thanks, Andy. That's great. I mean, that benchmarking exercise is genuinely super useful. No cost takeaway to spend 15 minutes doing, which you could save thousands of pounds as well as lower your CO2 emissions. So yeah, highly recommend it. Okay, next I'm going to hand over to Michael, our water systems manager, to talk you through Legionella control and what your responsibilities are. Over to you, Michael.
Thank you, Carl. So, what is Legionnaire's disease? So, it's named after a 3-day conference of the American Legionnaires Convention in 1976. So, American Legionnaires, think about old soldiers getting together, social events, basically talking what they did in the war. Okay, so 2,000 people attended and 25 people died. So, it was caught by the inhalation of contaminated water particles. So I think aerosols. Think every time, next time you have a shower, look up at the ceiling. If you've got a downlight, you see the tiny little droplets of water. That's an aerosol, and basically each one of those aerosols could have half a dozen bacteria particles in there. Basically, illness is caught by breathing those in. So 3 to 6 days after the inhalation of these particles, you can develop symptoms which include fever, a non-productive cough. Interesting thing about Legionnaire's disease is the cough itself. So think about if you ever had a cough or a cold, it's what we call a productive cough. So you're producing mucus. If you've got Legionnaire's disease, it's non-productive. So you're coughing, there's nothing there. Okay. So it's muscle aches, and quite often get diarrhea as well. So basically, to you and me, it is a flu. Okay. So and it's fatal in 9 to 10% of all cases. If it's hospital acquired, it can quadruple. So it can be to 40 to 50% of cases in hospital acquired, i.e. underlying health complaints, can lead to fatalities. Interesting about it as well, it's non-infectious, so it's not contagious. So if I was sat in a room with you today and I had it, and I was coughing this non-productive cough everywhere, you wouldn't catch it from that cough. Okay, so you have to catch it from the source, which is the inhalation of contaminated aerosol particles. So a little bit more about the bacterium itself. It's very common in the environment. It's waterborne, so it lives in streams and rivers, and it likes stagnant water. It's not particularly fast growing, but like I say, it likes stagnant water, so it likes to sit around and grow in such environments. It can survive under a wide variety of conditions. Temperatures between 20 to 45 favour growth. So 20 to 45 degrees is what we call the danger zone. And that's interesting what your body temperature is, 37, 38, which is basically the bacteria's evolved to grow in your body. It's killed above 60 degrees. Think back to your GCSEs and your O levels. We refer that to as pasteurization. So that heat basically denatures the cell membranes in the bacteria and kills it, cooks it. Below 20 degrees, the bacteria lie dormant and it won't do much. It won't produce much toxin. It'll just sit there, but it'll still be alive. Okay. So what we say in water hygiene is keep your hot waters hot. Yeah. Anything above 50 degrees at taps, so the bacteria basically going to be killed off, and your cold. Anything below 20 degrees, the bacteria is going to be dormant. So in society, who is more likely to catch Legionnaire's disease? We refer to these as susceptible individuals. Okay. So first group, smokers. Every time people inhale cigarette smoke, they're basically damaging the lungs, which makes them more likely to catch Legionnaire's disease. Alcoholics, excessive alcohol use will damage your immune system and basically make you more susceptible to Legionnaire's disease. Diabetics, unfortunately, they're more prone. I mean, as are those immunosuppressed. So I think people have basically taking drugs for organ transplants, that sort of things, or underlying health complaints. So, and the ratio is 3 to 1 for men to women who catch it. Lots of studies have been conducted and nobody's ever produced an answer. So, but men are 3 times more likely to catch Legionnaire's disease than women. And anyone over 45 years of age is more at risk. So, in summary then, Legionnaire's disease is caught by breathing in contaminated aerosol particles. So in your school, think showers, think spray taps, or irrigation systems. That's more likely to catch these or have these aerosol particles within your schools. So we're going to the law now, the legal hierarchy. So the primer law is the Health and Safety at Work Act of 1974. So specifically Section 2, that pertains to your staff and employees of the business, and Section 3 relates to visitors to school. So that'll be basically the parents etc., and contractors. So that'd be section 3. Okay. Health and safety quite clear. Health and safety executives, sorry, are quite clear. You create the problem, therefore you have to manage the risk. So I'm sure you've all read the Health and Safety at Work Act 1974 cover to cover, and it mentions nowhere in that document about Legionella bacteria. So where are we with that then? So the Health and Safety Executive very kindly and very helpfully have produced a series of guides. The first most important one is the L8 ACOP. I say guide, underlined guide, but it has special legal status, but it's not the law. So high level, it's quite a comprehensive document. So high level summary, basically 5 bullet points there. So you must have a management structure in place. Okay, so the management structure is quite clear. At the top of that, again, hierarchy is the duty holder. So usually it could be the head teacher, and underneath the duty holder works the responsible person, and the responsible person has the day-to-day control of Legionella bacteria. Okay. You must assess the competence of your service providers. Usually a demonstration that would be to use a contractor who's a member of the Legionella Control Association, which we are, of course. You must have a valid Legionella risk assessment in place, and you must have control measures in place, i.e. temperature and turnover. So Legionella risk assessment, high level, means somebody has identified the risks of Legionella bacteria in your water system and produced a document to list all the control measures which must take place to combat the growth of the Legionella bacteria and reduce the chances of illness. So yeah, control measures. So typically temperature and turnover are the most common ones. We talked about Legionella bacteria, 20 to 45 of the danger zone. So keep it hot, keep it cold, keep it moving. Yeah, they're the control measures. And you must ensure staff are trained and competency. There's a subtle difference between training and competency. Training is a classroom-based exercise, and competency is a physical demonstration of those classroom-based skills in the workplace. Physical demonstration, yeah, training and competency. So alongside the what's, yeah, the L8 ACOP, so that's what you have to do, are the hows. So the hows basically documented in HSG 274 Part 2. Again, these are all free downloads off hse.gov.uk. Very popular. They're always in the top 10 downloads from this government website. So if you haven't done it already, free downloads, I suggest you do it and have a good look at it. So a little bit more about HSG 274. In that, it is quite a prescriptive document. There are lots of good diagrams, basically, and explaining how water systems work and how the systems should be designed and run to combat Legionella growth. The best part of that document, or the most useful part of that document, I should say, would be Table 2.1. Table 2.1 is gives you a full list of water fittings, such as storage systems, water heaters, pipework networks, and basically gives you a time frame of what you must do and when. So an example would be storage systems. It must be looked at within the summer months and a full inspection, and if you find something wrong, then you must disinfect them. Okay. Showers, potential area of concern because of aerosol generation. So if they're scaled up and not in good condition, it should be cleaned, descaled quarterly, or as defined in the risk assessment. Temperatures, talked about keeping them hot and keeping them cold. So outlet temperatures, they should be checked on a monthly basis. Again, all in Table 2.1 of HSG 274 Part 2. Rolls off the tongue. So why are schools high risk? So we talked about Legionella bacterium itself. It likes time to grow. So that time to grow will be perfect in the summer months when the temperatures are elevated. Remember the danger zone, 20 to 45. So summer months, 6 weeks off. Where the water systems are not used, potentially that could be an area of concern. Define the definition of little use is every outlet should be used a minimum of once a week. So obviously the 6 weeks, that's ticking a lot of boxes. So yeah, so basically if you can't use it, simulate use by flushing and put things on an outlet register and flush. A lot of schools have complex plumbing systems. Having done quite a lot of reviewed quite a lot of risk assessments myself for schools, there's always storage systems that people are not too sure about where they are and what they're feeding. Same for water heaters tucked away in cupboards. Are they used? Are they not used? Outlets, water heaters, cleaners, cupboards, first aid rooms, craft studios are all locked away. Not so people don't know where every single outlet is all the time. So again, something to keep your eye on. And again, we talked about little used outlets. So every outlet should be used a minimum of once a week. Again, if it's not used, then it should be flushed. And remember, the building use is dynamic. So buildings might be used sometimes for different classes and not at others. So they're not always used at the same amount. First aid rooms are a classic example. Quite often they go unused for some time. So something to think about. And often you have aging infrastructure. So we're aware that schools have funding issues. So they've not necessarily had the love and attention and care that they should have had over the years. So again, it adds to the risk. So in summary, the key takeaways: must appoint a responsible person. So you've got to have your management structure in place from the start. Okay. And then once you've got that, you must have a Legionella risk assessment in place, a valid Legionella risk assessment, which is done a minimum every 2 years and reviewed. You must have a flushing schedule. So part of that risk assessment will be to identify little used outlets, and they must be flushed on a minimum of once a week basis. And once they're flushed, remember, you've got to sign your name against them, because if you haven't signed your name against them, potentially you haven't done it if the health and safety executive knock at your door. You must monitor temperatures. So that's water temperatures at outlets above 50 degrees from taps, and calorifiers stored over 60 degrees, and cold water must be below 20 degrees. So they must be monitored on a minimum monthly basis. You must clean and maintain your water systems. So that involves descaling taps, cleaning tanks, and sample where appropriate for bacterial growth. That's if you suspect the control measures have not been followed. And also ensure that your staff are trained. So ensure your caretakers and maintenance staff know the procedures, and we can help you with all these tasks. There you go. Thank you.
Fab. Thanks, Michael. I mean, just coming back from Easter when these hours won't have been used for a couple of weeks does emphasise the importance of managing that risk when it comes to Legionella control in schools. Okay, so that is everything we're sharing today. I think we've almost kept to our 20-minute promise. Not bad. As I said earlier, we ran this over lunch specifically to hopefully facilitate making it easier to attend. So please let us know if that's worked or not. And just in general, any feedback or comments on the session would be appreciated. Yeah, we'd love to hear from you. Contact details for myself and Andy are on screen now. Quick thanks to Michael and Andy for presenting today. Thank you, guys. And then finally, thank you for listening. We hope you found it useful, and hopefully we'll talk to you all very soon. So take care. Thank you.